So right here on this one's a little different, but we did see that on that other slide. I just didn't really go over it very much. So on these types, they're actually not so bad. What we're going to end up doing is we're going to treat this second absolute value like it doesn't exist. And the reason why that is because the distance from 0 is the distance from 0 no matter which side you choose, okay? So this side's distance from 0 is exactly the same as this side's distance from 0, positive or negative. So it doesn't matter which one you choose. I mean, you could do this technically 4 times, but it's not really going to help. Here's what I mean, is I'm going to take my negative 3x minus 1, because I always use the one on the left, and I'm going to split this up, okay? So I'm saying if I can get that negative 3x minus 1, if I could get it to actually just equal what's inside the other one, just the negative 8x plus 7, I'll get a true statement out of it. Okay, so that's one equation that I will end up solving. But the other one is where I take the negative 3x minus 1, but now it's going to equal the opposite of negative 8x plus 7. Now, I'm setting it up like this because it's it corresponds to what we were doing with like the 8s, right? You got one's positive, one's negative. Here's my positive, here's now my negative. But it's the whole thing that's negative. I need to make the whole thing negative. I like to show this step. Some students don't, and so they'll just say, all that means to me is I'm going to change the signs. Okay, that's fine. In fact, let's go ahead and do that right now, because the way that I have it, you'd be distributing a negative 1 into the parentheses here, right? So negative 1 times negative 8x's would be 8x's. See how it changed the sign? And then also negative 1 times positive 7 would be negative 7. So it just changed the signs there, but it does not do anything to the first equation, all right? Now I have 2 full equations. There's no more distribution, no more combined like terms. You're just going to solve it like you would a regular equation with principles of equality. I'll stick with that one on the right just because I already did some work with it. So let's stay there. So for me, I'm going to put my x's on the left, numbers on the right. You don't have to. You can switch them. You just need to end up with the same answer because it doesn't matter which side the x's are on. So that negative 1, I'm going to have to zero out by adding 1 to both sides. And that will zero that out. But also the 8x, I'm going to have to zero that out because it's on the number side of things, but it's an x term. So I'll subtract 8x's from both sides too. So what are we getting here? That zeroes out. Negative 3x's minus 8x's would be negative 11x's, which equals negative 7 plus 1 is negative 6. And then finally, we'll divide both sides by negative 11, which tells me that x would then be 6/11. Okay, well, there's one solution. We'll come back here, but I just want to check this. Okay, so I go to my calculator. On the left side, I've got negative 3 times 6/11 minus 1, enter, and my calculator gives me, from that, it gives me negative 2.63 repeating. Okay, now that was the left side of the equation, so I'm going to try the right side. Oh, but that was absolute value. So actually it was a positive in the end. So negative 8 times 6/11. I can type it in right, plus 7, enter. And yeah, it ends up being the same value. That right side, though, is positive on the inside of that absolute value, but it is the same value. It's the same absolute value. Okay, so that's true. Since it is true, I know this is one of the solutions. Let's see if we can find a second one. Well, let's start on this next one then. So same idea. I'm going to put my x's on the left, numbers on the right. So the negative 1 will be zeroed out by adding 1 to both sides. So that will zero out. But the negative 8x, again, it's on the number side of things. We'll have to add 8x's to both sides to zero that out. So on the left side, negative 3x's plus 8x's would be 5x's. And then on the right side, 7 plus 1 is 8. And then last of all, we just want this to be a coefficient phantom 1 and divide both sides by 5 to do that. Okay, so there's my 1. X then equals 8/5. That's fully simplified. You can have the decimal if you want it. It's like 1.6 if you care. But again, let's go back up to the top, and let's replace this x's with 8/5. Okay, so I got -3 times 8/5 minus 1, enter, and on my calculator, give me the fraction negative 29/5. Okay, now does it? That's the left side. Sorry, the absolute value that would have been positive. Now -8 times 8/5 plus 7, and that's negative 29/5 as well. But again, the absolute value that would have been 29/5. So this also is a true statement. So as strange as this seems, I guess there wasn't any mistakes there. But there's our two answers. So again, on the assignment, you just list these, type in 8/5, comma, 6/11. Doesn't matter which order you put them in, just put a comma between them.